Okay, great. Welcome back. So let's talk about the this matter of yield. So I'm going to do it both ways. And the first method I'm going to use is the method that I think I might have spoke about in class first and then went back to break up into the individual sort of inputs, if that makes any sense. So I spoke about output. And that's typically how this is looked at. And that's the real idea. We're interested in output. So let me do it the first way. And so the issue here is that we expect, and just to kind of prove, just to show you kind of what the principle is here, is that you put in a certain amount of product into a vat. You expect to lose a certain amount. And in this question, they're telling you expect to lose about 10%. And therefore we expect a certain amount, so 90% basically, to come out ultimately. And so that's kind of that's the thinking. So that's why this 10% is. So it's okay to lose 10% is what they're telling you. Don't get rid of 10%. You expect to lose 10%. Okay, let me see if I can clear my eraser link. Okay, great. So let's go back again and see the issue here. So from the front end of what I'm dealing with, let's look at what we're saying here. We're saying that we expect to put in, again, just take it step by step and just try. I'm more interested in you understanding what's going on, and then it's easy to kind of work through them as opposed to looking at them as formulas. So the whole idea is that you put in 16 kilograms of input into this thing, and you expect to lose 10% of input. So you expect that for every 16 kilograms that you put in, you expect to lose 10%, and that's 1.6 kilograms. And therefore, that leaves you with 14.4 kilograms. We expect that for every 16 you put in, 14.4 kilograms will come out, if you like. That's kind of the principle. So I'm expecting, on putting in 16 kilograms, 40. That's the ratio, if you like, right? That's kind of what we're arguing here. Okay, great. So from the first way I'm going to do this is I'm just going to look at it from that kind of output-y type point of view. So I'm going to pour in all of this thing into this vat. So where are we? So yes, let's just go to a clean page, and therefore, that's all of that. That's the 19,153. So I'm going to pour in 19,153 kilograms into this vat. And we expect to lose, I'm expecting you to lose 10%. That's kind of the principle, right? And so therefore I'm expecting you to lose 1915. So I'm expecting you to lose 1915, and therefore I'm expecting to come out of this vat, let me just calculate this, 19,153 minus 1915, which is 17,238 kilograms to come out. So the question here is what came out. Let's look at what came out. So oh good God, what's going on? 1 second. Let me just go back. So what came out? Let's go back to the question. We're told that 15,408 came out. That's what came out. Actual output was 15,408. So from a yield point of view, 15,408 came out. So from a yield point of view, less came out than we expected. So the question here is, let's find out what that is. So 17,238 minus 15,408 is 1830. I get 1830. I mean, you might get 1831, however. So 1830 kilograms, if you like, is the variance. This is an adverse variance. So now let's analyze this 1813 kilograms. That's kind of the issue here. So I'm expecting that, so again, like I said earlier on, coming back to here, that for every 16 that goes in, I'm expecting 14.4, if you like, to come out. So the question here is that this is the cost. Again, like I mentioned here, this is the standard cost of a kilogram that goes in. So I would have said, well, if I was going to cost this 14.4, really, because that's what I'm expecting to come out. Yes, this is the cost of 16 kilograms going in, but I'm going to lose 10%. So this cost is going to be spread over this 14.4 kilograms, right? Because that's what's coming out. Just think process costing. 16 goes in. Imagine this is stock. You've invested this kind of money in making, you've spent this into making this product. So you have 14.4. You're going to spread this cost over the 14.4 anyway. So here we are. So, let's just look at the standard cost of 16 kilograms, if you like, although it's really 14.4 kilograms. So that's what we're spreading it over. So we have 0.3 times 8, 0.5 times 5, and 0.4 times 3. That's what you've spent. So 8 times 0.3 is 2.4. 5 times 0.5 is 2.5. 3 times 0.4 is 1.2. So yes, what we have here is that you have a total cost of here we are, 4 plus 5 is 9, 9 plus 5 is 9 plus 2 is 11, 1, and you have £6 and 1. So ultimately, for every 14.4 kilograms, we have a cost of £6 and 10. So this is my standard, if you like, kind of costing kind of tool. 14.4 kilograms, £16.10. Let's just go back here. 14.4 kilograms, £6.10. So what we now have here is a variance of 1,830 kilograms. So 1,830 kilograms, if I'm costing that, I would say, well, 1,830 kilograms divided by 14.4 times £6.10, right? Because it's £6.10 for every 14.4 kilograms. That's kind of your standard. And when you do that, divided by 14.4 times £6.10, you will get £775.20. So this is from an output point of view, just that you poured this in, you expected this to evaporate, so you were expecting this to come out. This came out. Sorry, this came out. That's my kind of that's my variance. What is the value of this? Because this is about output, if you like. And output is no longer the 16 kilograms. That was input. This was the 14.4 output, really. So the output of 14.4 is worth, well, the total of 14.4 kilograms comes out, and that cost of £6.10 is really the value of those 14.4 kilograms, and therefore, if 14.4 is £6.10, what is it? I could find basically the cost of 1 kilogram, and then you can do it however way you want to do it. But the key point is that the ratio is 14.4 kilograms to £6.10. So I could find 1 kilogram. You could do £6.10 divided by 14.4. It's exactly the same thing I just done. £6.10 divided by 14.4 times 1830 to find my full answer. So that's the first method that I'm doing. And what I'm going to do is I'm going to pause there and what's the word? And in the second video, I'm going to go through the second method as to finding the yield variance with loss. Okay.